Ratios, rates, and proportions. Three things that need to be defined, and then three skills that align with all of those things. Uh, to just review the ways to write ratios, a comparison of two things that can be part to part, like I'm comparing like tires to broken down cars. There's not a part to whole relationship like how many tires out of all the tires are there. And then there's a part to whole relationship. And it's good to know when you're recognizing a part to part versus a part to whole. Part to whole is what you've been looking at normally with fractions. And although that ratios can be written like fractions, so it's comparing a part to the amount. So it's one amount compared to another amount. Sometimes that's all of it, sometimes that's another part of it. Like boys to girls versus all the boys in the class. That can be written as a fraction, a number over a number. That can be written as a number compared to another number side by side, or it can be written as a number to or out of another number. So this represents the part to part, and this represents the part to whole. So if you say number to another number, it's comparing two different parts. If you're saying it's a number out of another number, you're comparing a part to the entire quantity, the entire amount that is there. This is an example of comparing two parts and then comparing a part to the entire picture. So stars, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 stars. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 circles. Okay? We can simplify 10 and 15 using the multiplication chart. Find 10 over 15, and then it will go over to the left to 2/3. That is the simplified fraction. So it's saying there for every 10 stars there's going to be 15 circles is the same exact thing as saying for every 2 stars there are 3 circles. And here's how that works. If you have 10 stars, you can bet you're going to have 15 circles. Simple. Just making a comparison. Simplified is the same thing. For every 2 stars, you will have 3 circles. So although they are different numbers, the value is still the same. You're still comparing the same ratio. 2/3 is the same thing as 4/6, as 6/9, as 8/12, and then 10/15. Those are all equivalent ratios, and you can follow 2/3 on the multiplication table and see 10 over 15 as an equivalent ratio in that row. And then we have a comparison of the total amount of circles. So there were 15 circles to stars plus circles. So that would be all of it. So 10 plus 15 is 25. So we have a ratio of 15 out of 25. So out of 25 shapes, 15 of those are circles. That's all that's saying. You can go to 15 over 25 on your multiplication chart and scroll over, and then you will see 3/5 as a simplified ratio. That's saying for every 3 circles, there's going to be 5 total shapes. So look, for every 3 circles, out of 5 shapes, 3 of them are circles. Out of 5 of the shapes, 3 of them are circles. Okay. This is another example, but I'm not going to do it. All right, so the thing that we discussed, the thing that you should always be asking yourself, prompting yourself at the very beginning, are what are the two things being compared? Right now we have calculators and money. And all we do is set up a table. And this table is just basically setting up equivalent fractions. Because whenever we have stuff that is proportional, which is ratio, rates, and proportions, if we have equivalent ratios or equivalent fractions, we know that they're going to grow by the same amount. So whatever happens to the top number happens to the bottom number. So if it's being multiplied by 3 times the amount, you'd multiply the top and bottom by 3. So here's the information we've got. And to find a unit rate, all you have to do is find the cost of 1. Right now we know that 5 costs 140, but I want to know the cost of 1, and this is what our table does. And this is our mystery. The strategy we used is multiply the diagonal numbers. 140 times 1 is 140. And then divide by the number that remains, otherwise known as the bat and ball. 140 divided by 5. Let's take a look. Is 28. Okay. So what we're looking at here to summarize the answer we found. One calculator costs $28. And we could find how much 2 calculators would cost if we multiply the top and bottom by 2. And that's the benefit of having a unit rate. We could find out how many 100 calculators cost. If we know that one of them costs 28, we multiply the top and bottom by 100. And that's the purpose of a unit rate. And anytime that you have a rate, like 5 calculators cost 140, you can always turn it into a unit rate, which is how much did 1 cost. So the benefits of proportions is if you can find a unit rate, you can find how much any quantity costs, or you can find the comparison of any quantity. And that's the benefit of being able to use proportions. There's another twist on this, and it's, are they equivalent? Are these equal? Are these ratios that you could find, like if you tracked 2/3 on your multiplication chart, would these fractions pop up as being equivalent fractions? And there's an easy way to do that in elementary school. It's called the butterfly method. I don't really care for that, but it's also called cross products. And the reason is because it finds common factors between the two opposite numbers. So if you're multiplying by those two and they have the same common factors, then they're going to end up being an equivalent ratio. Excuse me. So 10 times 22 is 220, and 20 times 11, I don't think is 220. I'm going to check though. 20 times 11 is 220. Okay, so if that's the case, yes, these are equivalent. And let's just take 10/11ths and 20 over 22, and let me show you how 20 over 22 is equivalent to 10 over 11, or how 10 over 11 is equal to 20 over 22. If we wanted to make an equivalent fraction out of 10 over 11, we can multiply the top and the bottom by 2, and that would give you 20 over 22. That's why these are equal. You could also reverse the process and simplify 20 over 22 by finding 20 and 22 on your multiplication chart and scrolling over, and you'd find 10 over 11. It would be the fraction right next to 10 and 11. By dividing, reducing the fraction by 2, since they're both even numbers, you get 10 over 11. So this is why the process we're doing works. The common factor that I was talking about was 2. So whenever you do that, they're going to come up as being equal. So if you ever want to find out if they're equal, just multiply diagonally on both of them. If they have the same number, they're equal. This is the area that you're going to be utilizing the most, and this is also going to be where one-step equations start coming in 7th and 8th grade. So it's, again, pretend that we have the table set up. Okay, so like we could just do top and bottom. Multiply the diagonal, that's 30, and then divide by the number that's left, 5. So that gives you h equals 6. And you can always check it by doing 15 over 6, the answer we found, and 5 over 2. 5 times 6 is 30, and 15 times 2 is 30. That means your answer is correct. 6 is the correct answer.